Our next unit is going to look into some exponent and radical things, and to begin with we're going to look at roots and rational exponents and the connection between them. And so as we're talking about the term rational exponent here, you need to just recognize that we're looking at this value as being rational. Remember, a rational number means a fraction, and so we're going to have numbers taken to fractional exponents. So that brings it to a question here. What's a rational exponent telling us to do? And as usual, if we aren't sure what to do, we always kind of fall back on technology and we just go ahead and punch this in our calculator. And if we take 16 to the 1/2 power, calculator says it's 4. If you take 36 to the 1/2 power, the calculator says the answer is 6. So therefore, hopefully this leads us to an observation here. A 1/2 power, the 1/2 power of 16 is 4, the 1/2 power of 36 is 6. Well, based on prior information, hopefully you're thinking of this right now, that that's also true. The square root of 16 is 4 and the square root of 36 is 6. And that is true because these two problems are exactly the same. The 1/2 power is the same as a square root. So this is the connection between roots and radicals, is that roots are the same thing, a root or a radical is the same thing as a fractional exponent. So then that brings us to the question, what happens if we have a problem like 9 to the 3/2 power? So it's no longer just the 1/2 power. We know the 1/2 power is a square root. And so if we punch that into our calculator, 9 to the 3/2 power, the answer comes out as 27. And the reason why that occurs is this. I can think of this as 9 to the 1/2 power times 3. Because 1/2 times 3 would be 3/2. So therefore, this is really 9 to the 1/2 power to the 3rd power. Which means you take the square root of 9 to the 3rd power. The square root of 9 is 3. 3 to the 3rd power is 27. So here's our observation that we're making here. We've got a 1/2 power telling us it's a square root. A 3/2 power says take the square root and cube it. So therefore, here's what we're getting to for a rational exponent. A rational exponent is telling us this. If we have a to the x over y, x is the power, y is the root. So the number on top says raise it to that power. The number on bottom says take that root of the number. So if we have 12 to the 3/4 power, that is simply telling us you're going to take the 4th root of 12 to the 3rd power. And the order doesn't matter here that we do that in. But the bottom is always the root, the top is always the power. So that means if we can say that's the 4th root of 12 taken to the 3rd power, we can write that in another form, and that's what we're going to start looking at here on the next page. Is we're going to start translating our fractional or our rational exponents into another format that we've seen. So you see here on this page the two different formats that we're going to write these problems in. You have one in radical form and one in exponent form. So the top two are both written in radical form. They have a radical, and so this is the 4th root of 8x taken to the 3rd power. Based on what we just talked about, how you can write a fractional exponent such that the root goes on bottom, the power goes on top. So that's how we translate from a radical form into an exponent form using rational exponents. The value we're taking, 8x, doesn't change. We're taking the fourth root of it to the third power. The root goes on bottom. The power goes on top. So therefore, if I want to do the square root of x minus 2 to the fifth power, it is a square root. If there's nothing written here, it's assumed to be a 2. So my root is 2, the power is 5. So we would write that as x minus 2 to the 5/2 power. So then going the other way, if we're starting with a fractional or rational exponent and we need to write it as a radical, we would go ahead and put our root, it's the fifth root, and we're going to take that to the fourth power. For our last one, if I have x plus 3 to the 1/4 power, I'm going to have a root x plus 3, and that's a fourth root. And then to take it to the first power is unnecessary, so that will be our solution. So that's what we call translating, where you're just switching from one form to another. So the last step that we're going to do in our homework today is going to be around solving an equation using a rational exponent. So if you're given an equation like 3x to the 7th minus 14 equals 37, we're going to solve that by adding 14 to both sides and dividing by 3. X to the 7th equals 17. When you go to solve that, if we had x squared, we would take a square root. Well, the square root's an easy function in your calculator. The 7th root, however, is not all that easy. So if I want to get this, so the 7 will go away, I can take both sides to the 1/7 power, because that would get us x equals 17 to the 1/7 power, which is much easier to punch into your calculator. And that answer will be a big long decimal. I'm not too worried about the actual answer. You can find that in your calculator. But this is how you could use a rational exponent to solve. It gives you something to be able to punch in your calculator, similar to the square root method, where you could just punch in 17 to the 1/7. All right, good luck, and we will see you tomorrow.